All right, so let's share my camera. Okay. So what I'm gonna do, I'm gonna try to, the final exam review that I have on D2L, it's cumulative, which should be, and it's got everything. So what I'm gonna do, I'm going to try to narrow this down so you can have something similar to as much as I can, of course, to the final exam that you're gonna have, okay? So the first question, so this is 1540 final exam review. Okay, I gotcha. Okay. The first question is to rationalize the denominator. And please stop me if you have any questions, okay? At any time, so. Square root of 3 divided by square root of 3 minus 3. So in order to rationalize the denominator, you need to remove the square root from the denominator. So you need to times the top and bottom by the conjugate. And the conjugate of root 3 minus 3 is root 3 plus 3. And after multiplying by the conjugate of the denominator, then we distribute the root 3. So we'll get root 3 times root 3 is root 9 or 3 plus 3 times root 3. And then on the bottom, it's a minus b times a plus b. It's the difference of two squares. So it's root 3 times root 3 is 3 minus negative 3 times positive 3 is 9. Because if you do outer and inner, they will cancel each other out. And 3 minus 9 is negative 6. So you get 3 plus root 3 over negative 6. Let's divide negative 6 into each one of these to simplify. So 3 over negative 6 is negative 1/2 if we reduce it. And that's negative 1/2 root 3. And we have removed the square root from the bottom. It's on top now, but who cares, okay? As long as we removed it from the bottom. So that was the first question. The second question is about complex numbers. Again, I'm recording. If I go a little fast, I'm gonna post it on D2L this evening, so you can go over that one more time if you want. So the second question is about multiplying and dividing complex numbers. So simplify. Part A, if we have two complex numbers like 2 plus 7i times 2 minus 11i. So to multiply two complex numbers, we FOIL. So 2 times 2 is 4. And then the outer terms, 2 times negative 11i is minus 22i. Inner terms, 7i times 2 is 14i. And then last terms, 7i times negative 11i is negative 77. I times I is I squared, but we know that I squared is negative 1. So you have negative 77 times negative 1, which equals plus 77. So negative 77 I squared is 77. We add 4 to 77, we get 81. And then add the I terms together. Negative 22i plus 14i is negative 8i. And that would be the answer in standard form. Now, if we're dividing two complex numbers like 5 minus I over 2 minus I, again, to divide two complex numbers, just like the rationalizing part, we times by the conjugate of the bottom. The bottom is 2 minus I. Its conjugate is you change the sign of the I term. So you times by 2 plus I. Whatever you times the bottom by, you gotta times the top by to keep the balance of the fraction. So now we have to FOIL the tops and the bottom. So let's do that. So 5 times 2 is 10. And then outer terms, 5 times I is 5I. Inner term, negative 2I. And last is negative I squared. And remember, I squared is negative 1. Let's clean up the top, then we'll go to the bottom. So we have 10, and that's minus negative 1, which is a plus 1. 10 plus 1 is 11. 5I minus 2I is plus 3I. If we FOIL the bottom, 2 times 2 is 4. Again, this is the difference of two squares, so we can just do first and last because inner and outer will cancel each other out. So 2 times 2 is 4. Negative I times I is negative I squared. And remember, I squared is negative 1, so that's going to be 4 plus 1, which is 5. And it's 11 over 5 plus 3 over 5I. We divide the I into each one of these to write it in standard form. Please let me know if you have any questions at any point, okay? All right, so number 3, it's a story problem, so I'm gonna write it down. It's not too long. The number of grams A of a certain radioactive substance present at time t is given by the formula A equals 6e to the negative 0.0073t, where t is the number of years from the present. So t is years from the present. Find the amount remaining after 2 years. Find the amount remaining after 2 years. Find the amount remaining after 2 years. All right, so we have two variables here. We have A, which is the amount that you have present at time t, and t is the time, years from present. So if they want the amount, that means they want A, and they better give us t, and they give us t. All we have to do is plug 2 for t and do the work on the calculator. That's pretty straightforward problem, times 2. And if you put this in your calculators, so 6e to the power negative 0.0073 times 2, and that's 5.9 grams almost. Okay, that's the amount remaining after 2 years. You start with 6, that's your initial amount. And it's a radioactive substance, so it decays. So it decays from 6 grams to 5.9 grams in 2 years. That's what we just did, okay? Again, if I don't see a hand raised or you don't talk, that means I assume everything is good. I'm gonna keep going. If you have questions, please do ask at any time, okay? So number 4, it says solve the inequality and graph your solution on the number line. The inequality is a rational inequality. 5x minus 2 over x plus 3 is less or equal to 1. So to solve a rational inequality, we gotta first, it has to look like this if you remember. P over Q is less than 0 or greater than 0, okay? So you have to have 0 on this side, and you have to have a single fraction on the left side. 0, 1 fraction. We don't have a 0, so we're gonna make it 0 by subtracting the 1. 5x minus 2 over x plus 3 minus 1. Remember, 1 is 1 over 1 is less or equal to 0. So we got our 0, but then instead of having one fraction, we got two fractions. So we're going to find the LCD to make these the same. So we're going to times the 1's by x plus 3. So we would have 5x minus 2. This negative 1 has to go through x plus 3, so it'd be negative x or minus x minus 3 all over the common denominator. And now cleaning up the top, so 5x minus x is 4x, negative 2 minus 3 is minus 5 over x plus 3. Now we have 0 on the right side, we have a single fraction on the left side. So now we're going to set to find what we call critical values. We're going to set the top equals 0 and the bottom equals 0. And that's what my critical values are going to be. So move the 5 over and then divide the 4. So this is one critical value. Move the 3 over. So once we have the critical values, then we would plot them on the number line. Negative 3 is 3 units to the left of 0. 5 over 4 is 1 1/4. And we will use brackets because it's less or equal, except where the denominator is 0. The x plus 3 equals 0 and x equals negative 3. Why? Because if we put a negative 3 in there, it's undefined. So we're going to put bracket at 5 over 4, but parentheses at negative 3. So we have 1, 2, 3 test intervals. We know they will alternate as long as none of these factors show up twice. So none of them show up twice. There is no square anywhere. So we know they'll alternate. So all we have to do is check one of them. And then using the alternating method, we know which one is true, which one is false. So if you pick 0, which is in the second interval, plug it in the original inequality. So if you put x equals 0 in there, 4 times 0 minus 5 over 0 plus 3. Is that less or equal to 0? 0 minus 5 is negative 5. 0 plus 3 is 3. This is definitely true. It's a solution, meaning all the interval that contains 0 is a solution. The one before is not. The one after is not. That's what I mean by alternating. My solution set is interval 2, which is from negative 3 to 5 over 4, not including negative 3, but including 5 over 4. And that is solving linear rational inequality. Okay. Any questions? All right. Number 5. So we're going to solve a log equation and exponential equation. We want to solve and check our answers. The log equation, log of x plus log of x minus 3 equals log of 4. So since every expression has a log, we want to have a single log on the left side and a single log on the right side. We do have a single log on the right side. To make these a single log, we use the product rule because we have a product rule that says, again, let me remind you of these rules. If you have log of u plus log of v, that's log of u times v. If you have log of u minus log of v, that's log of u over v. And if you have r times log of u, you can write this as log u to the r. So these are 3 important log rules that we need to remember. Okay. Please mute yourselves because I know it's probably a dog or something is going on. Okay. So it's clear that we have log of x plus. So plus means we're going to times x and x minus 3 to get a single log. And once we have a single log equals a single log, and because log functions are one-to-one, if log of something equals log of something else, then we can drop the log. We're really not dropping the log. It's just the one-to-one property. If you look at the log function, if this is y equals log of x, which pretty much is, if I say x1, if I say log of x1 equals log of x2, that means x1 has to equal x2 because it's a one-to-one function. If the y values are equal, so the x values will equal. It looks like we're dropping the logs, okay? We're not dividing by, we can't divide the log. It's just because of it's a one-to-one property. So that's why we're dropping the logs. Now we get a quadratic equation, x squared minus 3x. Let's move the 4 over, and we can factor that. X minus 4, x plus 1. So x equals 4. And we gotta check. It's a log equation. We want to make sure if you put a number in there, you don't do log of negative or log of 0. So log of 4 is good. 4 minus 3 is 1. Log of 1 is good. And that's always log of 4. If you check -1, log of -1 is undefined. So we know -1 is not going to check. Okay. So the second question is an exponential equation. 3e to the x minus 1 minus 2 equals 7. So in order to solve an exponential equation, we want to isolate this exponential expression. So we're going to add the 2 first. 7 plus 2 is 9, and then divide the 3. Divide 3 into 9, you get 3. And to get rid of e, we do its inverse, which is ln. And whatever you do to the left side, you do to the right side. And since logs are one-to-one, we can do that. So x minus 1 equals ln of 3. 1 plus ln of 3. You can leave it like this, or you can get a decimal answer. Doesn't matter, okay? Number 6. So we're given f of x equals x plus 3. And another function g of x equals 2x squared minus 1. We need to find a couple of things. First part, f, composite f of 3. So basically what this means, it's like finding f of 3. So we always start inside out. So f of 3, we plug the 3 in there. F of 3 is 3 plus 3, which is 6. So we're going to put a 6 for f of 3. But now we're doing f of 6. So we're going to plug in a 6. If we plug in a 6 for x, it would be what? 6 plus 3, which is... So f composite f of 3 is 9. So what we did, again, we plugged the 3 into the equation of f because it's f of 3, and we got 6. And then we have f again to apply, so it's f of 6. We plug the 6 again for x, and we get 9. Part B, we want to do g of x plus h minus g of x all over h. So first, we're going to take x plus h and plug it into g because it's g of x plus h. If we plug that into g, we have the 2 up front, so we bring it down. We're going to plug x plus h for x, so it's x plus h squared because you have x squared, so we're going to square whatever is in there, which is x plus h, minus 1. That's g of x plus h, minus g of x, which is all that. And remember, it's minus the whole thing, so it should go in parentheses, all over h. We're not done until we have canceled out the h at the bottom. Keep that in mind, okay? So we have some work to do. We're gonna square x plus h, which is x plus h times x plus h. If you FOIL x plus h times x plus h, it's what? X squared plus 2hx plus h squared. And I brought the 2 down. And then bring everything else down. Minus 1, distribute the negative. So distribute the 2. we get 2 times x squared is 2x squared. 2 times 2hx is 4hx, and 2 times h squared. And then the ones cancel out. The 2x squared cancels out. And now we can pull out an h from the numerator. And don't forget, we still have an h at the bottom. Once that h cancels out, we know we're done. 4x plus 2h is the answer. This is the basis of calculus, okay? Limits are the basis of calculus, and this is the basis of limits. So this is really important if you're planning on taking calc class. All right. So now we're gonna solve a quadratic inequality. So solve the inequality and graph your solution set on the number line. X squared minus 5x plus 6 is greater or equal to 0. So we want to make sure first it does equal 0, and then we find what we call the critical values. So we find the critical values by setting it equal 0. Factor it. It's product of 6, sum of -5. So it's x minus 3, x minus 2. And then x equal 3, because x minus 3 equals 0, and x equal 2 if x minus 2 equals 0. And then we plot those on the number line, 2 and 3. Again, my intervals will alternate, and it's all brackets because it's greater or equal, and there's no fraction, okay? So there's interval 1, interval 2, and interval 3. And we're going to pick either one of them. The easiest one to pick is 0. We plug it in there. If 0 is a solution, then the whole interval is a solution. If 0 is not, then the whole interval is not. So 0 squared minus 5 times 0 plus 6. 0, 0, 6. It's true that 0 is a solution because 6 is greater than 0. So 1 is a solution, 2 is not, 3 is a solution. They alternate. Remember that.
I
So
had a quick
these,
question.
yes,
Sorry.
yes, please.
So, 0 is automatically a number that you put in there along with 2 and 3, right? Like in all critical values, 0 always exists.
Only reason, no, 0 is not a critical number. The only reason
Okay.
I put a 0 on the number line, so I would know where is my positive and where is my negatives.
Okay, okay, cool. Thank
That's
you.
the only reason. Okay.
Okay.
0 is not a critical value unless it is a critical. Like if my,
Unless that is critical value, yes.
exactly, like let's say you have x squared plus 5x is equal 0.
Yeah.
You factor out the x, then x is a critical value and you cannot plug x in. You have to plug something else in.
Okay, okay.
Got it?
Okay. Cool. Thank you.
You're welcome. So my solution set, we should always write it in interval notation. Interval 1 is from -infinity to 2, 2 included 2, so we put a bracket. And then interval 2 is 3 to infinity. And we put a union to say it's this or that. Okay, next I want to review a 3 by 3 determinant with you. So number 8, how do we find the determinant? 2, 1, 5, 0, 0, 3, 5, 1, 8. So usually we can reduce it along any row or any column. I'm just gonna do the top row. So the signs plus, minus, plus. It's always a plus up there and then they alternate. So we take the first entry, which is 2, plus means keep the sign of 2, times its minor. The minor of 2 is if you cross the row and column of 2, so you get 0, 3, 1, 8. That's the 2 by 2 determinant. And then you move on to the next one. Minus means change the sign of 1, so it's -1 times the minor of 1. Again, you cross the column and row of 1. And you see a 2 by 2 determinant, 0, 3, 5, 8. So you copy that down. And then keep the sign of 5. It's a +5. Cross the column and row. So it's 0, 0, 5, 1. And then it's evaluating 2 by 2 determinants. So it's 0 times 8 minus 1 times 3. 0 times 8 minus 5 times 3. And then 0 times 1 minus 0 times 5. So you get 2 times negative 3 is negative 6. Negative 15 times negative 1 is 15. And that's a 0, which is 9. Okay, next one is writing terms of a geometric sequence. So number 9, write the first 5 terms of the geometric sequence such that its first term is 2 and its common ratio is root 2. So you need the first 5 terms. You already have the first term, so you need 4 more, okay? You can do it in a couple different ways. The best thing to do is remember the nth term is a1 times r to the n minus 1. That's for geometric. If you're given arithmetic, the nth term is a1 plus n minus 1d, where d is the common difference, okay? And r is the common ratio. And an is the nth term or the general term. So we're given a1, which is 2. We're given the common ratio. It's like having f of x equals 2 square root of 2 to the power x minus 1. Same concept. So we already have a1, so we don't need a1, we need a2, so we're going to make n equal 2. So a2 would be 2 times root 2 minus 1, which is 2 root 2. And then n equal 3, a3, 2, you plug 3 in there. So root 2 squared, which is 2, 2 times 2 is 4. N equals 4, a4. Is there anyone who doesn't see how I'm getting these terms? Are we all good? So we're putting in a 4 for n. 4 minus 1 is 3, so 2 root 2 cubed. Root 2 cubed is root 2 times root 2 times root 2, okay? So that's a 2. 2 times 2 is 4, so it's 4 root 2. And then we need the fifth one because it says the first 5 terms. So a5 is 2 root 2 to the 5 minus 4. Minus 1 is 4. So each 2 root 2's is 2. So 2 times 2 is 4 times 2 is 8. And that's the first 5 terms. 2, 2 root 2, 4, 4 root 2, and 8.
Would you recommend that we just use the formula or actually multiply the common ratio?
You could. The only thing is, I'm worried if they don't give you the first term, they give you something else.
I see. Okay.
Yeah, but that's the other. Remember, I said there's a couple methods. So you could do.
Right.
If you have the first term to get the second one, you do a1 times r, which is 2 root 2. And then you take a2 times r, which give you a3. And then a3 times r gives you a4. And a4 times r will give you a5. Yeah, absolutely.
Okay. I don't know if you were going to show that now. Is there a way you can show us how to find the first term?
Well, there's probably something coming up. If not, I'll make.
Okay.
Okay.
Cool. Thank
Yeah, there's something that requires you to do arithmetic without the first term. I'll show you one coming up, which is going to be similar. Okay. So number 10, it says solve the system of your equations using the method of your choice. So it's a final exam. I'm not going to make you do a certain method. I'll just say use any method you want. So you tell me which method you think is easier, determinant, I mean using Cramer's rule, or you want to do elimination? If I were you, I would pick elimination if I have a choice. Would you pick something else? Okay. So if I want to do elimination, as long as I'm looking at X, Y, and Z, the easiest variable to eliminate is Y. So I'm going to add equations 1 and 2 because the Y's will cancel out. So add 1 and 2. So X plus X is 2X. Y's cancel out. 3Z plus negative Z is plus 2Z. And 1 plus 13 is 14. And if I see I can divide by 2, if I can divide by 2, then it would make my life easier. Why not? This is going to be my fourth equation. I need another equation that looks like this, which means I need another equation that has X and Z without Y. So I already added 1 and 2. Now I could add 1 and 3. That way I can eliminate Y. So 1 and 3, X plus 3X is 4X. The Y's cancel out. 3Z plus negative 5Z is negative 2Z. And 1 plus 3 is 4. Again, I can divide everything by 2 to make my life easier. So 2x minus z equals 2. That's equation 5. I'm going to bring equation 4 down here. And if I do elimination again, the z's cancel out. So I have 3x, 2x plus 1x is 3x, 7 plus 2 is 9. So I got 1/3 of the answer, 1/3 of the credit. Okay, you need x, y, and z. So let me just grab some papers 1 second. All right. So I got x, then I go back to equation 4 and z to get z. So I'll just go back to equation 4, x plus z equals 7, but x is 3. So z is 7 minus 3, which is 4. So I got x, I got z, now I need y. So I'm going to go back to one of the original equations, whichever one you pick. I'll just pick the first one. X, I already have x, which is 3. So I'll put that in there. So x is 3, y is the unknown, and z is 4. So that's 3 plus 12 is 15. 1 minus 15 is negative 14. Divide by negative 2. So x, y, and z. If you don't like elimination, you could do determinants using Cramer's rule, or you could do Gauss-Jordan elimination method if you want. As long as you know how to do this. Okay. Now, how do we find all real and imaginary solutions to the equation x cubed minus 3x squared plus 3x minus 2 equals 0? Well, if I could do grouping and it would factor, I would, but that's not going to work. So the easiest thing I would do using the rational zero theorem is I can do P over Q and all that. With the calculator, it makes my life a lot easier. So what I'm going to do, I'm going to graph it to see where the graph, excuse me, where the graph does cross the x-axis. That will give me an idea where to start. So if I graph x cubed minus 3x squared plus 3x minus 2. And I would do zoom 6 to get a standard graph. So it looks like there's only one real zero, and it looks like it's at 2, correct? If there's only one real zero and the degree is 3, there should be 3 zeros. So the other 2 must be imaginary. That's what this tells me. But let me double check to make sure that 2 is actually a 0. So I would go to table, second graph to go to table, and I would type 2 for x. Does it give me a y value of 0? It does. So I know that 2, 0 is a point on the graph. So it does actually cross the x-axis at 2. So I know that 2 is a 0. So now using synthetic division, I could divide 1, -3, 3, -2. If there's any missing exponent, then you put a 0 for that, divided by 2, because x equal 2 is a 0. That means x minus 2 is a factor, okay? This is the factor theorem, is a factor. So we're going to drop the 1 using synthetic division. 2 times 1 is 2. We put it under there. We add -3 plus 2 is -1. Again, one more time. You bring the 1 down. 2 times 1 is 2. You put it under the next column. Add these guys. And then repeat. 2 times -1 is -2. 3 plus -2 is 1. 2 times 1 is 2. And the remainder must be 0. And it is 0. And that's always going to be your remainder. And it must be 0 if 2 were to be a 0. This is a constant. This would be x squared. So remember, this is a factor. We bring it down. And then the other factor is x squared minus x plus 1. And that's how we factor the top expression. Now we already have this x equal 2. This is going to be this is going to give me my imaginary zeros. So we're going to use the quadratic formula. X equal -b plus or minus square root of b squared minus 4ac all over 2a. To get those imaginary solutions, we need the quadratic formula. That's not going to factor. So b is -1. The opposite of -1 is 1 plus or minus b squared minus 4a is 1 and c is 1 all over 2 times 1. And this comes out to be 1 plus or minus I root 3 over 2. So we get 2 imaginary solutions and 1 real solution. Okay? 2 imaginary solutions and 1 real solution. And it looks, you know, in the graph that there's only 1 real and 2 imaginary. Any questions? Okay. So next, I'm going to give you some graphing, and I'll tell you what you need to do on the test. And I really don't like it when I give a graph and I don't see a graph. I mean, people skip that. You have a graphing calculator. Use it. Sketch the graph showing intercepts and asymptotes if possible. Sketch the graph showing intercepts and asymptotes if possible. The first graph is f of x. It's an exponential graph, 2 to the negative x minus 3. Remember, with exponential functions, there's 2 basic graphs, okay? With exponential functions, there's 2 basic graphs. Let me put that on. There's 2 basic graphs. There's the exponential growth, f of x equals b to the x, as long as the base is greater than 1, and that's exponential growth. It has a y-intercept at 1. It goes along the negative x-axis, and there's the exponential decay one, when the base is between 0 and 1. So if you look at 2 to the negative x, that's like 1/2 to the x. So the base is between 0 and 1. So it's going to look like this. Only it's shifted what? Down 3. Okay? So the basic graph is the decay, but it's shifted down 3. So it's this guy, but it's going to go 1, 2, 3. So this is going to be right here. The x-axis is going to be y equal -3. So let me just do the graph here. So 0, 1 is going to go to 0, -2. If you go down 3, x equals 0, which is the asymptote, it's going to be x equal, y equals 0. Be y equal -3. And you just copy and paste the basic graph. That's all you need in there. 0, -2. Okay. That's all you need. The second graph is g of x equals ln of x minus 1. Again, for the log functions, there's two basic graphs. I'll just do them quick right here. It looks like this. It has an x-intercept at 1. If the base, that's log base b of x, if the base is greater than 1. And it would be decreasing. It has an x-intercept at 1 if the base is between 0 and 1. These are the two basic log graphs. So since we have ln has a log base e, and since e is greater than 1, then it's going to look like that guy, but it's shifted 1 unit to the right. So shift right 1 unit. So it's going to be this, shifted 1 unit to the right. So 1, 0, it's going to be at 2, 0. And then the y-axis, which is the asymptote, it's going to be at x equal 1. So let's do the graph. So 1, 0 shifted to 2, 0. That's your intercept. And then the asymptote, x equals 0, would be at x equal 1. That's my asymptote. And then copy and paste. And that's going to be the graph of g of x equals ln of x minus 1. The third one is a parabola. Again, you have calculators. You can check all of this, okay? It's a parabola that concaves down. It's gonna cross the x-axis at x equals 0 and at x equals 5. And you can find the minimum or the vertex at -v/2a. So you can do that yourself. And you have a calculator, you can use it, and it's gonna look like that. Okay. And then finally, the hyperbola, x minus 1 over x plus 2. Well, this you need to show the asymptotes. To find the vertical asymptote, you set the denominator equals 0. So you have a vertical asymptote at x equal -2. To find the horizontal asymptote, remember how we did that? If the degree of the top is the same as the degree of the bottom, you divide these two guys. So x over x is 1. So y equals 1 is a horizontal asymptote. And then to find the intercept, to find the x-intercept, you set the numerator equals 0. X minus 1 equals 0 when x is 1. And when x is 0, y is -1/2. So there's one graph, and then you can get the other graph by doing a t-table, or you have a calculator, use it, okay? Any questions about any of the graphing? Okay. Number 13. Find, this is what I was telling you about earlier. Okay? Find the 25th term of the arithmetic sequence that has a fifth term of negative 14 and a common difference of negative 5. Find the 25th term of the arithmetic sequence that has a fifth term of negative 14. So we need to find the 25th term. We are given the fifth term is negative 14. So A5 is negative 14. We are given the common difference is negative 5. If we use the formula for the arithmetic sequence, an equals a1 plus n minus 1d, if I want to find a25, I need a1. 25 minus 1, d is negative 5. I'm missing a1. I can find a1, but I really don't have to. I can use an easier way. So look, the trick is this. I don't know if you remember this. an, a1, and that's what? N minus 1, right? Where is this coming from? N minus 1. So if I want to find any term, a25, isn't that what I'm looking for? Which term am I given? Am I given a1? I'm not. Which term am I given? a5. So instead of doing n minus 1 common differences, we're going to do whatever these numbers are. 25 minus 5 common differences. And that's always going to work. Okay. Let me give you another example before we finish this. So look, say I'm given a7 and I need to find a18 without finding a1. So this is what I would do. I would say a18 is what I want. a7 is what I know. How many common differences between a7 and a18? It's 18 minus 7, which is what? What's 18 minus 7?
11.
And that's how that's how I come up with my formula. Instead of having to go find a1 and then put it back in and then do the problem. This is a lot shorter. Got it? Any questions? All right, so a25 is a5, which is negative 14, plus 25 minus 5 is 20 common differences. So the 25th term is going to be negative 100 plus negative 14 is negative 114. All right, number 14. Evaluate part A, the sum from 0 to 5 of 2i minus 3. All you have to do is do it manually. Plug in 0. So start at 0, plug in 0 for I. So 2 times 0 minus 3. And then plug 1 in. 2 times 1 minus 3. Plug 2 in. 2 times 2 is 4 minus 3. 3. 2 times 3 is 6 minus 3. 4. 2 times 4 is 8 minus 3. And then the last one is 5. 2 times 5 is 10 minus 3. That's all you have to do in this one, okay? And then you just have to calculate it, of course. So that's negative 3 plus negative 1 plus 1 plus 3 plus 5 plus 7, and it comes down to 12.
So you would include both the original like I equals term and the fifth term or whatever is on top of the sigma, correct?
You always start at the lower value and you keep incrementing this by 1 until you reach the highest value.
Perfect, thank you.
You're welcome. Now with part B, it's a little bit trickier. Why? Because it says n equal 1, which is fine, but it goes to where? Infinity. So we can't do this to infinity. We don't know what infinity is, okay? So there's a trick to that. So what we're going to do is we're going to write out the terms to see what that is. Just write out the first few terms. So this equals, if we plug a 1 in there, it's 0.3, 0.1, and 1 minus 1 is 0. If you plug in a 2, 0.1, 2 minus 1. If we plug in a 3, 3 minus 1. If we plug in a 4, and I'm going to stop after that. And then that doesn't stop. So I just write plus dot, dot, dot. So this would be 0.1 to the 0 is 1. 1 times 0.3 is 0.3. That's 0.3 times 0.1. That's 0.3 times 0.1 squared. And then 0.3 times 0.1 cubed. So obviously, and so on. Obviously, every time to get from one term to the next, we're timesing by 0.1. Do you agree? Do you see that? 0.3 times 0.1 gives me this. 0.3 times 0.1 times 0.1 gives me that. So it's a geometric series. And what's the common ratio? Is it 0.1? Yeah? And we know if, since the common ratio, since R is between -1 and 1, because 0.1 is between -1 and 1, this adds up to, this is equal to the sum of, which is A1 over 1 minus R. That's the sum of the terms of a geometric series as long as the common ratio is between -1 and 1, which is the case because the common ratio is 0.1. So A1 is the first term. What's the first term? Right there, 0.3 over 1 minus, what's the common ratio? 0.1. So that's 0.3 over 1 minus 0.1 is 0.9, which is if you times by 10 or move the decimal one place to the right. So this actually equals 1/3, which makes sense because it's 0.3 plus 0.03 plus 0.003. If you add them up, you're getting 0.3333 repeating, and it's exactly 1/3. Any questions? Okay.
Will there be any problems where R is not between -1 and 1?
If R is greater than 1, then it diverges.
Okay, cool. Thanks.
Okay, you're welcome. R is greater than 1 or less than -1. What I meant is absolute value of R is greater than 1, then it diverges. Okay. All right, then binomial expansion. How do we expand? A plus 3b to the 5th. So you can use combinations to get the coefficients, or you can do the shortcut. I'm going to show you the shortcut. I don't know if I showed that in the videos. I probably did. In order to expand this, the first term is going to be whatever that is to the highest power. And 3b to the 0, which we don't write. And then the next one, you keep decreasing this by 1 and increasing the second one by 1, 3b to the 1, because this is actually 3b to the 0. And then a cubed, 3b to the second. Remember, these have to add up to the exponent. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. And then you decrease the a by 1. You increase the second term by 1. And then you decrease the a by 1 and increase that. And finally, a to the 0, 3b to the 5th. And that's it. And you should have one more term than the exponent. 1, 2, 3, 4, 5, 6. That's a 5, so we're good. Now, how do you put the coefficients? If you don't want to use combinations, this is what you do. You put a 1, that's always a 1, and that's always an n, right? always a 1, always n. N is 5, so you're going to put a 5. It was 6, you put a 6. Okay? And then to get the next one, look what you do. You don't even need to know combinations. You do whatever that is. What's 5 times 4? 5 times 4 is
20.
divided by whatever that is plus 1. So what's 5 times 4? 20. What's 1 plus 1?
2.
2. So what's 20 divided by 2?
10.
That's the next coefficient. One more time. 10 times 3.
30.
Divide by one more.
So 30 divided by 3?
Which
No,
is? Yeah.
10. Okay, 30 divided by
And
3.
remember
Okay.
what it does? It increases and then comes back in a symmetrical manner. So if this is 10, the next one is going to be a 5. Let's check.
Okay.
What's 10 times 2?
20
Divided by?
divided by 3 plus 1, which is 4. So 20 divided by 4 is 5.
Which exactly what we guessed, right? The
Mm-hmm.
next one, which we know the last one is a 1, but let's check. What's 5 times 1?
5.
Divided by one more?
So 5 divided by 5 is 1.
That's how you can get your coefficients, always. Now you gotta clean this up. You cannot leave your answer like this. So that equals a to the 5th is a to the 5th. 3b to the 0 is 1. We don't need that. So you have 5a to the 4 times 3b. That's 15. A to the 4th b. You have 3 squared is 9. So that's 9b squared times 10a cubed. That's 90 a cubed b squared. You have 10a squared times 27b cubed. Why 27? Because you have 3 cubed b cubed. 3 cubed is 27. 27 times 10 is 270. A squared b cubed. 3 to the 4, b to the 4. 3 to the 4 is 81. 81 times 5 is 405. A, b to the 4. And a to the 0 is 1. 3 to the 5, b to the 5. What is 3 to the 5? 243. All right. Yes. Any questions? Thank you. Any questions? Okay. 16. So there's a couple more conics and we're done. Okay. So find the equation of the parabola with focus F at 3, 2 and directrix y equals -2. So find the equation. So we need the equation of a parabola with focus at 3, 2 and directrix y equal -2. So I need to know whether it's x squared or y squared, whether the center is at 0, 0 or I'm sorry, whether the vertex is at 0, 0 or somewhere else. In order to do that, I would do a rough sketch of whatever I'm given, which is the focus is at 3, 2. So that's the focus. And the directrix is at y equal -2. So I know the vertex has to be halfway. I know the vertex is halfway between the focus and the directrix. Okay, I know the vertex is halfway between the focus and the directrix. So if the focus is at 3, 2 and the directrix is 2 units away to the other side, so I know the vertex is going to be at 3, 0. Right? Is that halfway? Right? And I know the parabola has to open up. Because why? Because the focus has to be always inside the parabola. It cannot be on the outside. We cannot go like this. My parabola cannot cross its directrix, and it has to always be including the focus. The focus has to be inside the graph. So I know it's going to open up. So since it opens up, that means it's x squared. So I know it's x minus h squared equals 4p y minus k. That's how I know it's this form. It has to be x squared because it opens up or down. It's x squared. If it was right or left, it's y squared. HK are the vertex. So the vertex, we said it's at 3, 0. That's h and that's k. So x minus 3 squared, and we'll figure out p in a second, and then y minus 0. P is the absolute distance, it's the absolute value of the distance of because sometimes p is negative. Sorry. So p would be positive if it's concave up or to the right. P would be negative if it's concave to the left or down. Don't forget that. P positive if up or to the right. P is negative if it's down or to the left. Okay, so it's going to be positive, and it's that distance, which is what, 2 units, right? So P is 2. So 4 times 2 is 8, and that is the equation of the parabola with the focus at 3, 2, and directrix at y equals negative 2. Okay, last one about an ellipse. So write the equation in standard form. Find the foci center, and then sketch the graph. So we need to write the equation in standard form. We need to find the foci, the center, sketch the graph of the equation. 9 times x minus 1 squared plus 16 times y plus 1 squared equals 144. So in order to write this equation in standard form, we need to have a 1 on the right side. And to get a 1 on the right side, we got to divide by 144. And if we divide by 144, we can reduce the 9 with the 144. That's 25, I believe, or 16. So x minus 1 squared over 16. 16 goes into 144 9 times. And now we have an ellipse. It's centered at 1, negative 1. The opposite of negative 1, the opposite of 1. A squared is 16. So A is 4. B squared is 9. Remember, A is always the bigger value in an ellipse. So B is 3. So basically, the ellipse is centered at 1, negative 1. The ellipse is centered at 1, negative 1. So A is my x value. I got the 16 from x squared and the 9 from y squared. So A is an x value. So that means from the center, I'm going to go 4 units to the right and 4 units to the left to get a vertex. 1, 2, 3, 4. And then the B, which is a y value, we got those from the y value. So you go up 3 and down 3. And these are the 4 vertices of the ellipse. You can connect them and get your elliptical shape. And this is the major axis, that's the minor axis, and that's the center. Now to find the foci are c units away from the center. What's c? Remember, in an ellipse, a squared equals b squared plus c squared. We need c. We have a squared is 16. B squared is 9. So 16 minus 9 is 7. So c is root 7. So the focus, it's going to be on the major axis, the two focal points, the two foci. They're going to be root 7 units away from the center, one to the right and one to the left. The center is at 1, -1. So we're going to go root 7 to the right. So it would be 1 plus root 7. Root 7 is somewhere between 2 and 3. So 1, 2. So it's somewhere there. That's the first focus, or whatever you want to call it. It's at 1 plus root 7 and then -1. And then from the center, you go. That's the second focus. You started at 1 and then you went root 7 to the left. So it's 1 minus root 7, and you are at the y value of -1. And that's how you find the focal points. So you're always starting at the center, and you add c if you go to the right, you subtract c if you go to the left. If it was vertical, you add c if you go up, you subtract c if you go down from the center, from the x value of the center or the y value, depending on whether you're going sideways or vertical. Are there any questions? All right. If not, then I'm all set. I will see you Monday at 4 on Royal Oak Campus B. I'm sorry, A210, room A210. I will see you there for the final, right?
Thank you so much.
Welcome. I hope that helped. So
It did. I do have a question. Are there going to be about 17 questions on the final?
it's gonna be about the same number of questions that I did today. It could be one less, one more, but about those, yeah, about the same numbers. Okay. So the cumulative review that I have on D2L, it's a lot more inclusive, but in this review, I tried to pinpoint to the most important stuff from there.
Okay.
Okay.
I noticed you didn't cover hyperbolas. Is that something that we should still avoid, or?
Yeah, no, I picked two conics. That does not mean you should not do hyperbolas. So
Okay, cool.
what this means is if I ask about conics, it will be at most 2 questions. Yeah.
Okay, great. Thank you.
But for the most part, like when I did complex numbers, there's gonna be a multiplication and division. There's gonna be one about radioactive, similar to the one we did, rational inequality, so log equation, just to give you an idea what to focus on the most.
Okay.
Okay. You're welcome. Most probably the final will 90, probably I would say 95% what's going to be on the final is similar to what we did. Like I said, but if I did ellipse, that doesn't mean I couldn't ask about hyperbola. Okay. Got it?
Yes, thank you so much. Really appreciate this.
You're very welcome. Good luck, and I will see you Monday.
I have one question.
Sure.
So there was like one problem on the test that I think it was a hyperbola or it was ellipse, but it was a like it wasn't equal to 1, it was equal to 16.
Then you would divide by 16.
Oh, it was equal to 9. Okay.
Yeah, you need to write it in standard form. So you always want to, if it's a hyperbola or an ellipse, you need to divide by whatever number is on the right.
Okay.
All right.
Yeah.
Anything else?
Nope.
All right, guys. I will see you then Monday.
All right. Thank you.
You're welcome. Bye-bye.
Have a good one.
You too. Bye.